Okay, so this is going to be a relatively short episode. It's episode 4. We actually have that little potentiometer connected to a 0, and we're actually going to use it, interestingly enough, for what it says over there, a rotary angle sensor, but it is only an ordinary potentiometer. But of course in code we can read the resistance and convert that to an angle, as you can see it is doing on that little screen there. This is actually a little analog servo, and if you look carefully, this thing is supposed to run at 4.8 to 6 volts, and that is why I made up a little adapter cable that this plugs into. I can plug it into this port over here because that duplicates these pins, except this one has 5 volts available, and as you can see, it will actually work, at least with this ESP32C3 controller. Some of the controllers that you could plug in there may have a slightly lower voltage, and then it doesn't work too well, because obviously it's supposed to run on 5 volts and it wouldn't have the full torque available at 3.3 volts. And this is just one of those HY 2.0 sockets that exactly like those there, that I actually just soldered some wires on, and I put some tape on there to protect it so it doesn't break or anything. And so I can plug that into here, and it duplicates the same pins there. It's actually the UART pins, RX6 and RX7 or something like that, RX6 and TX7, something like that. And at 5 volts, of course, it would have, more power available. Now these things come in different sizes. You can get them in small ones like this, and you can get large ones for more powerful applications. These things were originally designed for RC type things, like models, like cars and boats and airplanes. And you can imagine in an airplane this could be controlling the rudders or the ailerons or something like that. And they actually come with different attachments. This is like a little star which I put on there so you can see the pointer's direction pointing, but you can mount a little wheel on there, or a sprocket or whatever, and control different kind of devices. In any case, as I said, you can see on the screen there the different angles. It goes from 0 to 180. As you can see, it's 180 now, and if I go back to 0, pointing in the opposite 180 degree opposite direction. It's running off the battery right now that is under here that I've shown in previous episodes. Turn it off. That's like that. So let's have a look at the code. Alright, so we are using 2 libraries. The usual one here that I've shown before for the little OLED display that's on that board, and we've got a analog write library over here. You'll find that library in the library manager in this guy, platform IO, but you'll also find it in the Arduino IDE, and the code will be entirely the same. So the code will be in GitHub, and you'll find it in the description, the link to it, and you could just kind of copy the code and paste it into the Arduino IDE if you're more comfortable using that, as I said in some of the other episodes as well. So the code is very simple. The only differences from some of the other episodes is that we now have a servo.h there, and we are using the same UG2 library, although we are using it in a slightly different mode over here, which uses a drawstring, and it has like a first page command And as I said in the comments over here, maybe it's a poorly chosen function name, I don't know. There's no comments in the actual code when you actually go there, but all it seems to do is clear the display and clear the buffer or something like that. Then the drawstring actually takes the text and it draws it pixel by pixel using that particular font that is actually defined over here. And then there is an OLED next page method here, which comes false as soon as the drawstring is finished. So that's why it says while it's waiting for it to finish, really. So it's kind of an odd bit of code. Before we were using it in the simpler mode, which is like a 8x8, and it actually has available like just a print line and so on, similar to what the serial interface has. But I thought I would try this, and of course I've got another little test somewhere that I was actually drawing little images and things on there so that you can do that with that. In any case, setup is nothing different there, except we have a servo attached for that servo module. Of course, the potentiometer again is on the A0 pin rather. So we are just reading the analog value from the potentiometer. We convert that to an angle. This comes back with 0 to 4095 on the ESP32. If you've got a different controller, it'll be a different value, probably 1023 max. You would have to change that over here. That's why it's defined. So in any case, we map it using those values to come back with 0 to 180, so that we actually have a real angle. And we then write that very angle to the servo. That's as simple as that. We don't have to do anything else. It's kind of nice, simple way of using it. And then we actually display the message on the OLED display what the angle is. My little rant here about C++, I hate this, having to use this sprintf thing and to do a print on it. Other higher level languages like C#, you don't have to run through hoops like that. But C++, it's kind of it's a botch job. Anyway, and then we have a delay of 15 milliseconds, I should say, because like if you were going straight from 0 to 180, it can take a little bit of time for the servo to complete its spinning its little control around. And that's it. It's as simple as that. So, as I said, it's going to be a short episode here. Don't forget to like and subscribe, and to be notified when there are new episodes. In some of the other episodes, we're going to do more complex things, and they will be a little bit more interesting and longer perhaps, but I'll see you guys then.